An alternative way to think of how we can get a solution for x equals -2 and x equals 8 is we can think of how can we make the absolute value function y equals absolute value of x cross the x-axis and at those 2 points. So if the absolute value graph here is crossing the x-axis and it's not crossing at -2 or +8, so if I move it around I can make it cross at those 2 points. Now to make that happen, because of the symmetry of the graph, the middle of the graph has to be in the middle of the two solutions. Okay, so it's got to be at x equals +3. So it has to be there. So I know that the horizontal shift of this graph then has to be x minus 3. And then to figure out how far down it goes, it's got to go down so that we have a distance of 5 here, and that means that we've got to go down 5 here. So we're just going to go -5, and there's our function that's going to cross the x-axis at those 2 points. Now to make this an equation, we just make this, it crosses the y-axis at 0, or the x-axis at 0, so we're going to make y equal to 0, and here is our equation then that will give us the solutions of -2 and +8, and we got that through manipulating the graph, shifting the graph of y equals absolute value of x so that it crosses the x-axis at those 2 points. And again, it still involves finding the center, just like we had here in the previous example. We have to know where the center is because of the symmetry of the absolute value graph, and in this case, we're using that distance from the center to the solutions to help us shift that down. And that gives us the correct positioning, and then it gives us the equation that we had. It's the same equation that we had previously.